All right, so now we're moving to the next part of our loose end series for Algebra 2. This is what the discriminant is. We are walking through what it means to solve a quadratic, what are the ways to solve a quadratic, what are the possible types of solutions, and so that's where we're headed now. This is part 3. So when you solve a quadratic, you can essentially end up with 4 possible scenarios. The first scenario that you learn about first is you have a quadratic that crosses your x-intercept at a very distinct point. So it might cross at -1, 0. You might have a root of 4, 0. You might have a root or a solution of -2.5. But in this case, you're going to have 2 rational roots that you can write as a fraction or a whole number. And you're going to learn that this is the situation when the discriminant, which we're going to talk about in a minute, is a perfect square. Then another scenario is you can have one distinct root, in which case the quadratic is a perfect trinomial square, so it can factor as x plus 3 times x plus 3, or the same factor used twice. And in that case, you end up with one rational root, meaning you can point to it. It's a number, a distinct number, a whole number, or a fraction, an integer or a fraction. But it comes from a factor that's used twice. So it's a double root, or it has a multiplicity of 2. And so it bounces off. Then you can have a situation where you clearly have 2 distinct roots, but when you work through the quadratic formula, it ends up being a rational, an irrational number. So the number under the square root does not, the radicand does not simplify fully. And so you don't have rational roots, you just have 2 real roots. They're real roots, but they involve a rational expression, so that square root is still in the solution to your 0. And then the last case is when you have the graph does not cross the x-axis at all. And that's what happens when you end up with a discriminant or a part underneath the radical that is a negative number. So there's no roots that you can point to. So you would have 2 non-real roots. And here's the situation with all the discriminants. And again, the discriminant is the part underneath the radical in the quadratic formula. So it's that b squared minus 4ac. And so we're going to work through a couple of examples here, 4 examples actually, one of each type, so that you can kind of see how that plays out. So this first one we're going to do, we need to get it in standard form first. So we're going to subtract that 7x from both sides of the equation. Then we identify a, b, and c. A is 6, b is -7, and c is -3. And then we just substitute in -7 for b, 6 for a, and -3 for c, and then evaluate, and we get b squared minus 4ac is 121, which is a perfect square. So when the radicand, when the discriminant is a perfect square, then we end up with 2 rational roots. So in this case, we're going to end up with 2 rational roots because that discriminant, the value of the discriminant is 121, which is a perfect square. The next case scenario we're going to look at, we've got to get it in standard form first, obviously. Then we identify a, b, and c. A is 2, b is -10, and c is -5. We do the calculations for the discriminant, and we get -10 squared is 100, minus 4 times 2 times -5 is 40, so we get 140. That's still a positive number. The discriminant is still positive. It's not a perfect square, but it's positive. So that means we're going to have 2 real roots, but they're not going to be rational roots. That square root's still going to be in our 0. Then the next case scenario, standard form, 3b squared minus 6b plus 3. We identify a, b, and c. And then we evaluate the discriminant. B is -6, a is 3, c is 3. So we end up with 36 minus 36, which is a discriminant of 0. That's when we have a bounce off of the x-intercept, or one real rational repeated 0. And then finally, we're going to go to the last example. We've got to get it in standard form first. 4r squared, we're going to add the 4r to both sides, plus 6 equals 0. Identify a, b, and c. And then evaluate the quadratic formula, the discriminant of the quadratic formula. We get 16 minus 96. That ends up being a negative number, so we have a negative number under the radical, which means we have 2 non-real roots. And that is the way that you determine the nature of the roots from a quadratic.